Okay, our next types of transformations are going to be vertical and horizontal shrinking and stretching. I will apologize in advance. Often I'll refer to shrinking as compressing. So if you hear that word, compressing and shrinking are the same thing. A vertical shrink stretch, again, vertical happens to the Y. It is going to be stretched vertically as long as your A is greater than 1. And so you could see where the A is located out in front of the function. If A is between 0 and 1, then it's going to be shrunk vertically. Okay, usually, typically, and I'll say typically because it really depends on what the graph looks like. Typically, a stretch vertically is going to make the graph slimmer toward the y-axis, kind of like stretching a rubber band. And then a shrink is going to make it wider, and it's like pushing it away from the y-axis. And then a horizontal shrink stretch is happening horizontally, which means it's happening to the x. We can tell this because it's inside with the x. So if A is greater than 1, then we're going to have a horizontal shrink by a factor of A. If A is between 0 and 1, you're going to have a stretch. And again, this has to do with how it affects is affected on the clear to the x-axis. So if it is shrunk, it's pushing it away from the x-axis. If it is stretched, it's going to seem like it's pushing it toward the x-axis. Okay, here you see we've got a quadratic parent function, which I've already put on the graph. And we're going to do f of x equal to 1/4 x squared. Well, 1/4 is a vertical shrink. How do I know it's vertical? It's vertical because it's out in front. It's 1/2 times the function x, or 1/4 times the function x squared. And so how does that affect my graph? Well, if we're shrinking the graph by 1/4, then we're shrinking it vertically. That's important. If we're shrinking it vertically, then we are basically taking 1/4 of all the y values. So 0 and then 1/4 of 0. 1 and 1/4 of 1. 2 and 1/4 of 4. 3 and 1/4 of 9. And then 4 and 1/4 of 16. And so what happens is you'll see that makes that graph actually stretch out. It doesn't increase as fast. So I still got 0, 0. But like 2 is at 1. And 4 is at 4. 1, 2, 3, 4. So you've got this parabola that's really wide because we have shrunk it vertically. So we've pushed it away from the y-axis. Now, what does it look like when we do a stretch? Well, 4x squared is a vertical stretch. And again, anytime you see vertical, we know we're going with the y. So this is what happens to y. So my x is not changing, but I'm multiplying my y by 4. So that would be 0. Then 1 times 4 is 4. 4 times 4 is 16. 9 times 4 is 36. And 16 times 4 is 64. So you see these numbers are going up much faster, still at 0, 0. But now 1 is at 4. And 2 is way up here to 16. I don't even have that scaled on my graph. So I've got this graph going up here. So this is g of x. Let me label this other one as f of x. And you can see that a shrink pushes it away from the y-axis and a stretch pulls it toward the y-axis. So let's look at another example. This time we're looking at horizontal shrinks and stretches. Notice it's horizontal because it's in the square root with the x. And so let's think about what's going on here. We're actually affecting the x values by multiplying the x's by that value first. So let's think about what's going on. In reality, what we're really doing is we are going to multiply the x by 5 and then take the square root of it. So let's look at that. I don't often do it, but with the horizontals, they're a little more confusing. So I'm going to kind of take a pause here and say, okay, if I put 0 in here. Well, 5 times 0 is 0. The square root of 0 is 0. So I'm still at 0, 0. Okay. If I put 1 in here, 5 times 1 is 5. This becomes the square root of 5. If I put 5 in, 5 times 5 is 25. The square root of that is 5. And then 6 times 5, and that's 6 times 5 is the square root of 30, which is hard to graph. And then this would be the square root of 35, which is also hard to graph. So I'm really looking at this one and this one to show me where the graph is going. So I'm going to take this and I'm going to actually graph this one in red. And so 0, 0 is still there. 1 became the square root of 5. 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. My next point's up there. So I've got this graph that is shrunk. It's pushed away from the x-axis because I multiplied my x values by 5 before putting them into the function. So let's do that on this one. So this was what we would call a horizontal, hold on, let me do it in the right color. This would be what we would call a horizontal shrink. Okay. This one is what we would call a horizontal stretch. Okay. And I'm going to do the same thing here that I did on the other ones. If I put 0 in, oh, let me put a different color. Because we want to graph in a different color. So if I put 0 in, 0 divided by 5 is 0. Square root of that is 0. If I put 1 in, 1 divided by 5 is 1/5. The square root of that is 1 over 5. If I put 5 in, that gives me 1. So the square root of that is 1. 6 would be 6. The square root is 6 over 5, which is not really helpful. These numbers aren't actually that helpful. 7 would be the square root of 7 over 5. And look what happens. 0, 0, still there. But now 1, 2, 3, 4, 5 is at 1. Look how narrow that is when compared to the x-axis. So that's a stretch. So let's look at one where we're taking it straight from the graph. So this is going to be a horizontal because it's inside with the x, and it's going to be a shrink. So how can I take this on the graph? Well, one of the things you need to remember is that everything that is inside with the x is opposite. Because if you think back, if we have x minus h, then we're moving right. That's opposite of what you would think would happen, right? X plus h is going to be a left movement, opposite of what you would think happened. You would think negative is left, positive is right, but it's not. So when we have ax, we're going to do opposite. We're shrinking it. So that means we're going to divide by it. Okay, so when we're trying to pull points and we're trying to divide, so this point is 1, 2, 3, negative 1. So the point over here is actually going to be negative 3 over 4, negative 1. So negative 3 over 4, negative 1 is going to be about right there. Because it's a shrink of 4, so we're going to divide it by 4 or multiply by 1/4. So this point is at negative 1, 1. So this becomes negative 1/4, 1. So negative 1/4, 1. So that point's right there. So this is the first part of my graph right here. This point is at 1, 2, 3, 4, 1, 2, 3. So it's at 4, negative 3. So on this side, it's going to be at 1, negative 3. So 1, negative 3. So there's the next part of my graph. And then this point is at 6, 3. So over here, it's going to be at 6 over 4, or 3 halves, 3. So 3 halves is 1.5, 3. And there's my point right there. So again, when you are doing those horizontal shrinks and stretches, remember they're opposite. So if A is 4, then I'm actually going to divide by 4 or multiply by 1/4.